All right, let's go ahead and get started. Hi, everybody. How are you doing today? So, just awesome. How many of y'all slept last night? Anybody? Anybody not sleep last night? Yeah, okay. Well, before we get started, I want to give out a shout out to Joseph Ledford. Are you here? Joseph Ledford? Is that you? Do you go by Joseph or Joe? Joseph? If you looked at Blackboard last night, you found that Joseph caught a bug in my program. I had a 6 where I should have had a 5 in one of my constants. And because of that, he wins the grand prize, which is an A for, is a full-size Snickers bar. Here you go. Congratulations. So good job. Round of applause. That just goes to show, I tell you, people range from imperfect to suck, and I am also somewhere on that scale. Okay? So. No. All right. So everybody should have turned their project by now. How was your project experience? Thumbs up. How many of y'all felt you learned a lot? How many of y'all thought it was kind of fun? How many of y'all suffered and thought it was miserable? Well, fun and suffering should not necessarily be, I guess maybe they're not mutually exclusive, though probably they should be. How many of y'all are looking forward to the next project? Good. Well, the next project is already posted. It's project 2. If you look on Blackboard, you'll see there's a link to my website. In case you're wondering why the projects go up on my website instead of Blackboard, it's that I like having them publicly accessible so that, students like you who want to look back at past semesters can do so. And the problem is if we post everything on Blackboard, it's like this black hole that disappears after the semester's over. So that's why all the projects are getting posted on the webpage. So the project's up. The good news is that the people who are on the epidemiological study that you're participating in are happy with your programming. The bad news is that they're asking more of you now. And so what they're doing is they have these collections of data files, and the data files have information about each subject that's enrolled in the program. And as this is the information mostly that you gathered last time, right, to do the Framingham risk score. Now, however, they're doing blood tests on the subjects, and they're getting something called the C-reactive protein count. And C-reactive protein is an indication of inflammation in the body. And it can be a predictor of heart disease. So they're getting blood additional information in terms of like the C-reactive protein count. It comes in a big data file with all the information, and they would like you to compute something called the Reynolds risk score. And the Reynolds risk score is similar to the Framingham risk score in that it gives you a % chance of having some sort of cardiac event over the next 10 years. It's different to compute because it's just one big equation instead of like lots of little points you have to add up. So it's just one giant equation. So your task is to write a program that will take these data files. We'll read each line of the data file. Most of the lines in the data file contain information about one of the subjects, and compute the Reynolds risk score for that subject. They also want you to compute the average of all the risk scores for people in that particular data file, and they want you to output the results to a file as well. Now, of all those things, how many of you know how to read lines from a file? Yeah, nobody, essentially. How many of you all know how to write things to a file? Nobody, essentially, unless you've programmed before. How many of you all know how to do loops, while loops? Yeah, we haven't taught that. So we're going to be covering that today and next class, okay? So we'll get through it. It may not, you'll have to start thinking about your algorithm, but you may not be able to fully complete everything ahead of time, okay? So the project's up. There'll be 2 phases. Due 1 week from today is the design document. Very similar to last time, using the same language. We've added one more construct, which is a loop, a while loop, so you can do things over and over. For the while loop, you'll be using the loop to read the file. You'll essentially say, while I read a line out of the file and there's some data in there, process that data, then go and read the next line. Okay, so the loop allows us to go back, read a line, go back, read a line, and you'll see how that. Okay, everybody good on that? You can take a look at the assignment. If you haven't already, bring questions next class. So, any questions right now? Not about the project, about anything? Yeah?
So I was wondering, is there a way to sort of figure out what errors mean?
So the question is there a way to sort of figure out what errors mean?
As in, when you get an error
Yeah.
from the project.
If you remember, like the the first day I told you that what was going to happen is that the compiler was a rude piece of software, that it would give you error messages that don't necessarily make sense. And the reason is that there are a wide variety of errors you can make, and whereas the compiler will give its best guess as to what the error you made is, and will give you a message about its best guess of error, it may not actually be the right error. Does that make sense? Because you can make a lot more mistakes than the compiler writers can anticipate. So often the error message is correct, right? Often the first error message is correct, but other ones are not necessarily. The other problem is that the compiler does its best if it finds one error to continue with your code after that to tell you about other errors. If it gets the first error wrong, then everything that follows is also probably wrong. So when I talk to you about debugging, what do I tell you? Just look at the first thing the compiler says. Don't worry about the rest. Just fix the first one, because sometimes fixing that first one will solve some or all of all the following ones as well. Does that make sense? So the answer to your question is no, but I was more polite than just saying no. All right. Other questions? How many of y'all wish you started this project earlier? How many of you thought you have more time and we'll start the next one later? That's a trap. Okay, just checking. All right, good. So I'm glad, most people here, nobody looks excessively sleepy. That's what tends to happen. Project 3 is where people get into trouble. So, all right, last time we talked about math.h. Anybody remember math.h? What is that? It's a header file that you include that gives you access to the math library. Somebody emailed me and asked me about CMath. There's also a thing called CMath, which is a header file for C++ that gives you access to the C math library. It is very similar to this. There are some internal functional differences, which I will explain right now. Magic. Okay, there's some slight differences. They make no difference for you right now. Okay, so you can use math.h or you can include CMath, whichever one. They're pretty much the same. We talked about math operators and the precedence in which we do those. Somebody name a math operator. Divide, plus, square root. Is square root an operator? It's not. An operator is a thing that has a symbol, right? Like plus, minus, divide, mod. A function, we have math functions that have parentheses. They are different. Right? And we talked about the precedence. What is the precedence of these things? Please, friends, excuse my dear Aunt Sally. Parentheses, functions, exponentials, which we don't have. Multiplication, division, addition, and subtraction. What do we actually do in practice instead of trying to remember this? Use lots of parentheses. And if you read code, you'll see that lots of people program with parentheses to force execution in the order that they expect. Innermost parentheses to outermost. Okay, I recommend that. The next project has a very large and complicated function, math function. But if you look at it carefully, you can break it down into many small pieces and then add all the pieces together and then do the math in one step instead of trying to do one giant thing. Okay? And I'm telling you that now, you probably won't remember that, and then next class you'll come in and you say, holy shnikes, that was a giant math equation, how do we do that? And I'll just tell you that again. Okay. All right, we talked about additional assignment operators that allow you to do math at the same time, right? Like plus equals, minus equals, divides equals. Those allow you to do math and store it in the same place it came from. We talked about the increment and decrement operators. What is the increment operator? What does it mean when you put the plus plus before the variable? Do the math and then use it. So if you're going to use it as in a function or to output or something like that, if it's plus plus x, it will increment x and then use it. What does it mean when it's after the x plus plus? Use the value and then increment it afterwards. Okay. Some people write code that does that, and it can be annoying to figure out. And then we started into strings. What are strings? Things that tether your kite to the ground. Yes? A bunch of, exactly, a bunch of characters put together in a clump that we can use to spell words. So guess what we're going to continue on with today? Strings. So let's go back. This is the code that we were writing for strings last time. And the important things to notice about this is that we had #include string. which allowed us to use strings. If we didn't have that, the compiler would complain and say it didn't know about strings. And then we declared one string named Clay, and we initialized it all in one step. And then we declared a string called office phone, which we did not initialize. We output name, then we set office phone to something, and we output office phone. And we can just go back and check and make sure this works. Oh, and let me just show you something here really fast, because by now somebody has probably run into this. If you are in this and you start typing something like ST and you push the tab key, it will autocomplete. Did you see that? So I am not just typing RING so fast that you can't see it. I'm hitting tab. And if I push tab a couple times, it'll show me what the options are for completing this. So if I push dot, it'll fill out .cc, like that, right? Make sense so far? Because computer geeks are lazy, we make our computers do the work for us where we can. And then I type -o, and I push string, and it completes string for me, right? What's going to happen if I hit enter now? It'll compile, and it compiles cleanly. And if we look, we're fine. Now let's say that I remove, and RM is how you remove a file, I remove that executable file string I just created, okay? And here's what I do. I say g++ string.cc -o, and I start typing string, and I do this, and I hit enter. What's going to happen now? What's going to happen? What's going to happen is it's going to take this string.cc file, and it's going to output it into the string.cc file. So let's watch that happen. Ready? This is a disaster, by the way. Congratulations. Now our code is gone. And if I type more string.cc, this is what allows us to see what's in there. It says, uh-oh, it's a binary file. Do you want to see it anyway? And if we type yes, we get this. And this is the binary code that the computer can execute. So what just happened to my string.cc program? Where is it? It is gone forever. Bad. Okay? So be careful when using autocomplete. This happens typically once a semester or twice a semester where students get programming and they do this. So you have to be careful not to overwrite your own code. Now, fortunately, I have my editor window up here. If I just make some changes and I type, it's saying it's changed, I type yes, and it should save yes. Okay, so now I rewrote what was in my buffer, and it's back to being code again. It's back to being source code. So you must be very careful when using that -o not to overwrite your source file, because that is bad for you. I would recommend, if you take a look at what's in here, if I list things that are named string, you can see I have string.cc. I also have this thing string.back. Every once in a while, what you can do is say copy string.cc to like string.cc .back, or whatever you want to call it. And now I've just made a backup of that file. Okay? So you can make little copies so that you don't accidentally overwrite it. All right? Everybody kind of good on that? That is just a warning that I probably should have given you earlier. Has this struck anybody yet, by the way? Not yet. Okay. All right. So let's get back to what we're doing. Here's our thing. If we go back and actually compile correctly, then we can run, and we see that when we run, it outputs some stuff. And we're happy, right? Great. All right, let's talk about some other stuff strings can do. Let's say that instead of having this set, what we really want to do is, we want to input a name and a phone number. Okay? So we give a little output message. We say, please enter name. CN into name, because that's how we read things, right? Yes?
You don't have to initialize?
No. With strings, you don't have to initialize them, because the magic that is the string library will automatically initialize them for you. Okay? You don't have to initialize strings. They're by default empty, which is nice, right? All right, our phone number. All right, so we're just going to read in the phone number and then we'll print them out. Does that look good? Everybody happy with this? Let's give it a shot. You're not happy. Why are you not happy? Oh, thank you. Office phone is what I should have said. Is that better? Okay. So let's see if that works. Good, it compiles cleanly. Let's go ahead and run it. Enter name. How about we use my name? Clay Shields. And, uh-oh. Didn't work. Let's try it again. String Clay. Oh, that's better. 202 4. Oh, I better give my own office number instead of my home number. All right. Wait a minute. That didn't work either. Right? What happened? Yeah. What? Yeah. So you remember when we talked about using CN before? And we were doing division, and we asked for two numbers, and we put a space between them? CN saw that space as something that broke the input in two, right? It broke it in two. And that creates problems for us, right? So here we are, we want to enter somebody's name, Clay Shields, and weird stuff happened, right? The first time what happened is it got name, it just did weird stuff, right? Enter phone number, and, oh yeah. So I can actually tell you what happened here. Let me just clear the screen and we'll do this again. So Clay, actually let me just change my code a little bit so we see what's what. All right, so now when it prints out the name and the phone number, we'll see which is which. Okay. So we'll compile, we'll clear the screen, now we'll run it. So we enter Clay Shields, and here's what happens. It goes, hey, I was asked to enter name, Clay, and we know that a space is what we use to separate different things. So when I see that space, I'm going to stop. And now it says enter a phone number, and it goes, well, I'm entering something, but I still have the shields that the user typed to take care of, so I will stick that in the phone number. And so we never even get a chance to enter the phone number, and then it goes, oh, the name is Clay, and the phone number is Shields. Everybody see that problem? How can we solve that problem? Streams? Is that what you said? Yeah, we're not going to get to that. Easier way. Yes? We could do no spaces, but that would be annoying, right? So, how, yeah. Well, we could tell it how many strings to expect. How about this? How about instead of name, we do first name and last name? How's that? Does that look good? So we can do name, and then we can do put stuff into the first name, and then put stuff into the last name. I do need to put the underscore. Thank you. All right. How's that? Does that look good? Thumbs up? Thumbs down? You want to do phone number too? Okay. Sounds fine. And we'll put a space between the two. How's that? Yep. Well, phone number might not work well. We'll cheat on that one right now, okay? All right, so everybody see what we've done? We had this problem where if we had a string that contained spaces in it, CN essentially breaks input apart by looking at the spaces. Right? CN breaks that apart by looking at the spaces. And I'm going to tell you after this, we're going to take a closer look at CN and how it works, because it does some other weird stuff as well. But right now, we just need to know that it breaks on spaces. Okay? Everybody good with that? Yes, sir. That doesn't matter. It'll break as long a white space as you have. And we can show that actually. So, all right. So let's compile the code. We'll clear the screen. We'll run it. Clay Shields. And the phone number 687-204. Hey. That worked, right? Because it looked at the first one, it said first name, last name, and the phone number, I didn't put any spaces in there this time. And it worked perfectly. Yes? How do we account for people who are stupid and they say things like Thomas C. Shields, which is actually my full name? Do we have to have like first, middle, initial, last? Okay, so here's the problem. If you're reading strings, there is not much you can do to get the user to enter something correctly, right? For example, first name, last name. There is a computer scientist. He is a professor. He publishes papers. His full name is Robbie. That's it. His name is Robbie. That's his whole name. He has no last name. Where he comes from, they only use for one name. So his name is Robbie. So he probably has problems where every program in the world yells at him for not having a last name, right? Because that's what we expect. So here's the problem we have, is that when we're inputting strings, depending on what the string is, we may or may not be able to tell if the user is going to do spaces or not. Everybody see that? Everybody understand our problem? How do we fix that? Yes? Yes, there is. That's exactly it. So there's two ways we could fix it. One way is we could try and force the user's input to fit the pattern we're matching. And you might go to some websites where you like enter a phone number and it yells at you and it says the phone number must have parentheses and a dash in the middle. Or it'll just yell at you because it has some way that they want you to input. Do you all experience that? How many of y'all like that way? I mean, it's easier to program because you can force the user to do what you want and everything is consistent. It's bad for people. So here's what we do. There is a thing instead of CN that is called getLine. GetLine. And getLine will read a whole line at once. So here's what I'm going to do. I'm going to create one string that we're going to call the whole name. And what we're going to do is we're going to use getLine to read the whole name. Now the way you use getLine is you say getLine, which means get everything the user types up until they hit return, including any spaces. And this is where you get it from. Now we've just been using CN before. When you see CN, what should you think? Keyboard, right? When you see CN, think monkeys pounding on keyboards. Okay? Later, I'm going to show you there are other places we can get data from, including files, and getLine will work on a file. And you just have to replace CN with the thing that represents the file. But CN, for our purposes, means keyboard. So this means get from the keyboard the whole name. And down here, we'll do getLine CN office phone. And down here, we'll just make this output the whole name. Okay? So, everybody understand what we're doing? We have the problem with strings. Strings contain spaces, but CN breaks on spaces. So we use getLine instead because getLine will get the whole thing at once, including any spaces. Let's just see if this works. Who thinks this is going to work? I think it's going to work. Mostly because you all didn't tell me it wasn't going to. So, all right. want to try it and see? Yell out some more names. I'm getting tired. Jacob what? Okay? Because it's a string, it will just read everything up until the end of the line and use it. And this is very useful. If you're doing string input and you don't know how that input is formatted, you should use getLine. If you're doing string input and you know exactly how it's formatted, that is how many spaces and pieces there will be, you should use CN. Okay? Does that make sense? If you don't know what the user is going to type, or if you don't know if you're reading from a file what the file format is, use getLine. If you have a very specific format that you can trust and expect will happen, use CN. Everybody happy with that? All right. Cool. All right, so let me just save this. So that's going to be one of our sample files, and we'll go back and do some other stuff. All right. So strings are kind of cool, and the reason that, yes, question? So you asked me, if you're going to use getLine, is it in pound include string or pound include IOStream? And the computer scientist answer is yes, because it's in one or the other of those. I believe it's an IOStream, but I couldn't tell you for sure. So I don't think it's part of string, because you can use getLine for other stuff too. So I'm guessing it's an IOStream. All right. So let's show you some of the other stuff that we can do with strings. Because strings are coming out of a library, we can do some magical stuff with them. Okay? And I'm going to delete the input stuff because we'll just be working with some strings directly now. So let's say that we wanted to assign the first name to something. How can we assign first name to something? Does this look familiar? Okay. The other way we can do it is like this. And the idea is that string, because it's a library and it's something that's provided, it has these things, and they are called methods. Methods. And method is something that you can access that's part of that you access by putting a dot and whatever method you are using. So here, string has an assign method, and assign means essentially the same thing as equals. And let me demonstrate to you that this works. So we say first name equals, last name assign. These are actually equivalent. And if we compile this and we run it, oh. What? Oh, I know. Sorry about that. I switched the file name. It's actually string2. No wonder I was confused. Okay. And you'll see that when it prints out clay shields, right? The clay was assigned to the string by using the equal sign. The other thing was assigned using the method. This is important. Right here, this dot something is important. What is it called? What is it called? A method. A method. The string has a method named assign. To access a method, you put a dot after the variable name, not after the type. You can't say string assign. You have to use a string of type a variable of type string dot assign, and you can use it. Okay. Does that make sense? Yes. There is no benefit. The benefit to you is that I can show you how to use methods using something you already understand, right? Because you know how equals works. So I use a sign to demonstrate methods and to show you you can do other things. Yes?
So you don't need to have the
For this, there are still double quotes in there because it's a.
you don't need to put it into the
No, this is a variable, so it doesn't get quotes around it, right? Literal. It's like it would be like saying 2 if it was an int or something like that, right? The variable has a type and a value, and you can assign it with a literal. If an integer literal, we just use the numbers, the raw numbers. With strings, we put it inside double quotes. With characters, we put them inside single quotes. Yes? Do you have a question too? I could have, yes. It depends what you're trying to do. You can do either. If you're using a string and at the time you declare it, you know what it's going to be, you can just go ahead and declare it. If you're using a string and some point later you're going to set it to something, you can do that as well. It all depends on what you're doing in your algorithm. Okay? If you want to use .assign instead of equals, you can do that as well. But the point of doing it this way, instead of setting it all at once, is I wanted to show you what a method looks like. How do we know a thing is a method? It's got a dot, and it comes after a variable name, and it always has these parentheses as well. Okay? It's like when we talked about math functions, you recognized it was a function because of parentheses, right? Methods also have parentheses. And strings define some of these methods. Later in the semester, we'll see how to write methods ourselves. Everybody on board right now? Yes? No. We'll talk about how to declare them later. In fact, method is something that will never show up on our code. Method is not a word we'll ever use. We'll use it to talk about it, but it's not like a C++ code word like for or while or something like that. Okay. All right. Who's with me on methods? Right now, just remember there are some things that have these magic methods that you can access by putting a dot and then something. All right. Everybody good with that? All right, we're going to stretch in place, shake it out for like 1 minute, and then we'll talk about some of the other methods that the string class has to offer. You can like talk. You sit in silence all the time. You have a minute to not sit in silence. And look at you all. All right. How y'all feeling? It's kind of low energy in here today. I should get out like some disco ball or dance music or something. Let's see if that would help. All right, so we've just been introduced to this incredibly magical and power thing called methods. And how do you recognize something as a method? A dot and then parentheses. So it's a variable name, dot, some method name, and parentheses will show you something as a method. So let's talk about some other methods as well. Let's say, now that we've read the first name and the last name, and we know what they are, we want to combine them together into the whole name. Whole name. How might we do that? Any ideas? Pardon? We can somehow put the two strings together. Okay, we will somehow put the two strings together. I'm going to show you a couple of ways to do this. First, what we can do is we can say it's equal to first name plus last name. Would it have a space in there? Who thinks there'll be a space automatically? Who thinks there will not? Because the computer is just a brainless, mindless, number-crunching grinding machine that does what you ask it instead of what you want. Let's run it and see what happens. And we run it, and it puts a space in there. What? Oh, because I didn't change my output. Whew, that confused me. It was like everything I've known for 20 years is wrong. Okay, let's try that instead. That might work a little bit better. All right, so we can see that using the plus took the first name and last name and jammed them together, but it didn't put a space in there. How do we put a space in there? With some quotes. So what we can do is we can literally just put a string literal in there and put quote, space, quote, plus. How many of y'all think that's going to put a space in there? Go with that? Let's try it and see. It's a beautiful thing about this class is we can just always try it and see. And that worked. Have I already made the guarantee to you that pretty much no matter what you do, you're not going to erase your hard drive or lose your data? Right? There's nothing I'm teaching in your class that if you execute it, will just delete your whole computer. It just won't happen. So feel free to experiment. You're probably not going to do any harm. Okay. Probably. Offer void where prohibited. All right, so we can add things that way. The other thing that we can do, if we want, is we can build things incrementally. Right? We can do something like this. Because plus equal also works. So here we say whole name, which is not initialized anything, plus equal first name. What does the plus do? Adds it on, concatenates it. And then we say plus equal quote, plus equal last name. And what this does is it says, okay, add this to the beginning, then add this to the end. But the string is empty. So if you add something to the end of the empty string, it is where? Because when we declared it, by default, it's empty. We don't have to initialize strings. So we know it's empty, and we append this. Plus equals means add that to the end. So if you add something to the end of the empty string, where does that thing appear? At the end, but it's also at the front because it is empty. It doesn't have any end. Right? So we add that. How many of y'all think this is going to work? Yes, that works as well. Okay. The other thing we can do is the method called append. Like that. Append is the same as plus or plus equals. And it says just stick this on the end. And boy, I hope this works because I never actually use it. Yes. I always just use the plus because it's way easier than typing append. Does that make sense? So, different ways of doing the same thing. The plus sign will append things onto the end. Or you can use plus equals, which does it in one step. Or you can use append if you're particularly energetic because it requires typing like 7 more characters than just the plus sign does. All right, everybody good with this? Pretty straightforward. Now, one of the things that's often useful is to figure out, given a string, how long it is and what individual characters in it are. Does that make sense? So say, for example, somebody entered, I don't know, let me think of an example. Let's just say somebody entered their name and you wanted to know how long it was, and I cannot think of a compelling use case for this, which makes me a failure as a professor. Let's say you were standing in front of a class and you needed a compelling use case. All right, never mind. Okay. We can figure out how things are, how long things are. by using what's called length. There's a length method, and we can say length of string is equal to whole name dot. Anybody want to guess what this is? Yep. Let's get rid of this phone number because we're not actually using it for anything. All right. Anybody want to guess how long length is ahead of time? What is length going to be? 12? All right, let's see. See if that's right or not. So I will compile the program that now includes length. I will go ahead and enter some stuff, and it was 12. Why is it 12? 1, 2, 3, 4, space counts, 5, 6, 7, 8, 9, 10, 11, 12. Okay, does that make sense? So you can tell how long the string is. This will actually be useful later on for different things, as you will see. Let's say, everybody good with length? That's pretty straightforward. How did we get the length? We used a method named length right here that returns a string. We just use the variable name dot length, and we get the method. Yeah? So the reason is for here. Okay, so the question was, and this is a good question, why in this method did we put shields in quotes, the assign method, but why in the append method did we just put last name not in quotes? And why is there nothing in length? Excellent question. So let me just explain the difference, even though I will answer the question you didn't ask. And the answer is that different methods have different things that they require to work with. These are called the parameters. The assign method and the append method take one parameter that has to be a string. So a string can either be a string literal with quotes, or it can be a string variable. This one's a variable, which is why it does not have quotes. This one is a literal, which is why it does. And then the question is, why does length have nothing inside there? And the answer is that the append method does not need any input, right? If we're going to append something, we have to tell it what to append. If we're using the length and it has nothing in there, the length, the parentheses are there to make sure that we know it's a function. But all the input, everything it needs to do the computation, is already stored in the whole name string. So we don't need to tell it anything about how to do. Okay. Does that make sense to everybody? Is this getting a little bit dull? This is not the most exciting part of the lecture, I guarantee. That part comes when I catch my equipment on fire in a few minutes, so pay attention. All right, so the length is there, right? And that'll tell us. Let's suppose that given the length of the string, we wanted to get a particular single character out of there. How would we do that? I will give you a hint. There is a method called, and let's just say, let's declare a char, because a single character out of a string is a character, right? We'll call this element, and we'll just initialize it to a space initially. And what we can do is we can say a particular element of the string, did I mess something up? Is equal to whole name, and we use the method called at. Now, does the at method require some input? It does, because we have to tell it which one we want. Which character do we want out of there? Who can get me to the Y in Clay? Which one's that going to be? 4? All right. And let me just output the element. Okay. So now what we're doing is we're saying we're going to declare a character. We're going to pull a single character out of this whole string using the at method, and we're going to find the thing that's at position 4, which should be a Y, right? How many of y'all think this is going to work? How many of you are not raising your hands because you don't see anybody else raising your hands? How many of you think this is going to fail? How many of you are not sure? All right, let's find out. So I compiled and we run it, we say, Clay shields, length 12, but element seems to be empty. Doesn't it? Well, we asked it for the element at position 4, and what happened? Well, here's the deal. Computer scientists, like myself, are generally horrible, horrible people. When we count things in strings, we start counting with 0. Okay? We do not start counting at 1, we start counting at 0. So here's the deal. If we want to look at clay shields and we want to figure out where the y is, 0, 1, 2, 3. So the y is actually element number 3. What's element number 4? The space. The space is number 4, which is why it looks like we didn't get anything. So the length will tell you how many characters are in there, but if you want to get a particular character, you have to start counting with 0. Okay? Now, there is a reason that computer scientists start counting at 0, which I will never explain to you. But there is a reason for it. Maybe I'll explain to it someday later, but not right now. All right? So, which thing do we have to do to get the y then? Element at 3 instead. So we'll compile it, we'll run it, and this time we said element was at 3, and we got the thing we wanted. Okay? Yes? Yes. Okay. So everybody understand that the length tells you how many characters are there, but if you want to get a particular one, you start counting at 0. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So there are 12 characters in there. They are numbered from 0 to 11. Right? Everybody good with that? Like when I give you a question like this on the exam and I give you a string and I tell me what element number 7 is, you're going to be able to do that, right? Because that's almost certainly an exam question. And that's not even one of the fake ones that I give just to scare you. Okay. All right. So the question then arose, what happens if we ask for an element that is outside the range of our string? What happens in this one, right? They're numbered 0 through 11. What happens if we ask for a different one? Which one do you want to ask for? 15? So we're going to ask for an element that's outside the range of our string. Is this going to compile? How many of you think this is going to compile correctly? It is. How many of you think this is going to run correctly? Abort. Abort. Here's what happened. When the program ran, it said, oh, I will go to get element number 15 out of that string, and it went, and the string only had 0 through 11. Element 15 was past the end of the string. And so the program said, screw you guys, I'm out of here. And it just died, right? It just died. Yes? There are ways to catch these errors and correct them, or at least ignore them. So, does that answer your question?
Well, yeah, I'm just like, is that the method itself doing an error check?
Yes. The method is what? The method in the string class, when it says give me string element number 15, the string class goes, wait a minute, there's no 15. I quit. And it dies. Does that answer your question? We could also try doing something like a negative number. Can you have a negative element? This may not even compile. It compiled, but it died the same way. Okay. All right. So that's what happens if you go past the end of a string. The important thing to remember, length is the number of characters, and then at gives you one of them, but they're numbered from 0 to length minus 1, right? Instead of 1 to length, they are numbered 0 to length minus 1. Everybody good on that? Because it's going to be on the exam, and like 25% of you will miss it historically, even though I emphasize it. Yes? The dot length method just counts the number of characters? Yes. starting from 1, it tells you how many there are. But if you go to access them, they are numbered from 0 to length minus 1. Always. Okay. Everybody got that? All right. Let's see if there's anything else we need to talk about strings. Those are big ones. Okay. We can also do some comparisons between strings. For example, if we wanted to check a string to see if it matched something in particular, so we could say, you know, string awesome equals Clay. Obviously, that's what comes to mind for all you. Then what we can do later is we can say something like, you know, if first name equal awesome, then we can output, you know, whoever is awesome. Oops, sorry, need the plus sign there. There's a lot of ways to do these various things, so. So we can actually compare strings to see if they're equal. Does that make sense? And let's just see if that works. No, because we still have this element minus 1 there. Say 7. We'll just pick a random number. All right. Now, all the times that I tell you a computer does not know what it's talking about, it's just a mindless mechanical calculating machine, this is the exception right here. Tough audience today. Okay. All right. We can also compare strings, not just for equality. We can do less than or greater than. Right? So, I don't know. Want to try it and see? Thank you. So we can compare these strings. Less than. So it said Clay is less than Shields. I forgot a space there. Yeah. So it turns out it's alphabetical. Okay? It's alphabetical, but it's alphabetical in a very strange way. Okay? So here, I'm going to go back and I'm going to, instead of assigning, I'm going to do some input. How's that? So we can actually do some more comparisons. Okay, so we'll ask for a first name and last name. We'll do a whole bunch of stuff, and then it will compare and tell us whether they're great or not. Okay? Everybody with me? I did that really fast. Yeah. So here's what I did is I replaced the static first name equals Clay, last name equals Shields with an output staying prompting for first name and reading first name, prompting for last name, reading last name. I did it relatively poorly because I'm not using getLine, right? So we have to be very careful to stick with single names. We do something that computes the whole name. We do something that computes the length and an element. We print out some stuff. We test to see if the first name is a particular name, and then we do a comparison to see if it's greater than or less than. Okay. All right. Everybody ready for this? The part that we're really focusing on is what it means for one string to be greater than or less than another string. Because it's alphabetical, sort of. Sort of. All right, you all ready? Everybody on the same page? I know I just went really fast there. So if I've gone too fast, let me know. Nobody's willing to say I went too fast. Yeah? I did not. I changed them to read from input instead of being statically defined. So we will have the opportunity to enter the first name and last name on the keyboard. Yeah? Because what I'm doing here is I'm outputting a string, and the string is made of first name combined with is less than combined then with last name. We could, in fact, replace those plus signs with double angles. I prefer using plus signs instead of double angles because I am lazy, and I get to type one less character. Adds up over time. So. You're laughing. Just wait. If you were like ever a computer scientist, you will be arguing with your friends over whether like holding down the shift key and pushing one thing is more or less than pushing two other keys and stuff like that. All right, maybe that's just me. Maybe that won't be you, but it's possible. Okay. All right, so let's go ahead and run this. We have a first name. All right. Frank is greater than Einstein. Does that make sense? It does, right? Because alphabetically, F in Frank comes later than E. Let's see what happens if we do two E's. The name is Elliot Ebert. Elliot is greater than Ebert. Now, why did it do that? Yeah, because it said E is the same. Let's look at the second letter. L is further than. All right. Yes? Okay, let's try Elliot and Elliot. Now, why did that happen? It's because our logic sucks, right? No, seriously, we just said less than otherwise. So what'll happen is this one will catch the equals as well. Do you want me to throw an equals phrase in there and we can see? Let me think about this a second. I'm going to do it up here, okay? Thank you. All right, so I've messed up my indenting. Let me just go ahead and then re-indent it. Ah, that was a bad idea. Where am I? Semicolon. All right, now that's better indented. So, all right, so now what we're doing is we're checking to see if they're equals. Otherwise, we're checking to see if it's less than, otherwise greater than. We should have covered all cases now, and we can recompile, and we can run it, and it says they're equal. All right, let's throw a wrench in the works. Yes? Let's throw a wrench in the works. Element? Oh, element was just a variable that was holding one of the characters that we pulled out at position 7. So it was just a character that we're pulling. Yeah, it's just pulling one character out of there. We could delete that. Okay, so now we made the first name Elliot and the last name Elliot, but we changed the capitalization. Is this going to make a difference? How many of y'all think it'll make a difference? How many of y'all think it will not? What's going to happen? Which is going to be greater and which is going to be less than? Capital B greater or less? Lowercase is greater. Okay? Now, what we're seeing here is a reflection of the fact that characters are actually what? Integers. And so when it's comparing these things, it's looking at the integer value. And it turns out that in this code list called ASCII, capitals come before So if I search for an ASCII table, and I go to one that doesn't look like it's going to display something horrible on the screen without. Try something else. Table of ASCII characters, yes. So here is essentially the code lookup. And it's pretty small to see, but so E actually is the code number 69, and lowercase e is actually 101. Let's try it. So the request was to do lowercase Elliot and then uppercase Smith. Now, let's try lowercase Elliot and lowercase Smith. So the way that these things sort is not completely intuitive up front, okay? It sorts based on the way you would do it, alphabetical, but instead of alphabetical, upper and lowercase matter because of that hidden code number stuff, okay? I'm just showing you this. I don't actually think we'll use it this semester, but it's there. All right. You can also, instead of equal or greater than, less than, you can do something called compare. But all right. 2 more methods we need to learn for this because they are actually potentially very useful for us. Okay? Potentially very useful. Let me just clean up this code a little bit. I'm going to create a third string file, and I'm going to clear out some of this cruft that has accumulated. So we can enter first name, last name. We can make a whole name. We don't need the length or the element anymore. We don't need element, but we need length. I take that back. Okay. So we figure out the length. We print out, we don't need element. We're getting rid of that. And I'm going to get rid of this comparison for right now because we don't need it, but it'll be in the file on Blackboard. Okay. So here's what we have right now. We have input the first name, input the last name, make a whole name out of the two, and then figure out the length of the string. Okay. That's not the soundtrack I would have picked for this class. All right. So here's what we can do. One of the things that we often want to do is, given a whole string, extract some small part of it. Does that make sense? So for example, let's say that we want to extract like the first 4 characters. The first 4 characters. What we can do is we can say something we'll just output it directly. So what we're going to do is we're going to see out whole name dot substr. What this stands for is substring. Substring. And what substring has is it's a method. How do we know it's a method? Variable name dot parentheses. This one takes 2 numbers. The first is where to start taking the substring from, and the second is how many characters. So let's try 0.4. What this will say is, given a string, start in position 0, which is which position? The first one, because we start counting from 0. And then we take 4 letters from there. And so we can just output this. Let's clear, compile. And now we're working on string 3 dot string. So what this did is it said, okay, first name's Clay, last name's Shields. If we join them together into a whole string, it's Clay space Shields because we put a space in there. The length of this is 12, and if we take a substring starting at position 0 for 4 letters, we just get Clay out of it. Yes? So, okay. So the question was, what if we had a bunch of numbers and we wanted to pull out a subset of the numbers? The answer is, it depends. If you have an integer, if you have an int that has a whole bunch of digits, you cannot use substring to pull out that. And the reason is that substring is a method that belongs to the string class and the string class alone, right? There must be some other way to do that. I would just be honest, I would not want to have to do it because it's probably annoying. Not hard, but annoying. And just like computer geeks are lazy, computer geeks don't like doing annoying things. Hard things are fine, but annoying things suck. Yes, with the string, right? So the dot says, given the string, find the method that belongs to the string that's named that and do things with it. Now the question is, can you have strings numbered? Yes, you can have strings that are numbers, and you wanted something from like the 50th to the 54th digit, right? Like that. That's what you asked for, right? If I'm not mistaken. So let's compile that. We'll run it. All right. There you go. Except I did that wrong because instead of 50 to 54, I did the 50th place and 54 numbers after that. Sorry. So, but yes, if a string can be any character set. It doesn't have to be English characters. It can be numbers. It can be punctuation. It can be all spaces. I've already told you that ASCII, I've mentioned this before, right? I showed you the ASCII table. It had just some stuff in it. Right? If we look at this, here are some characters. There are not very many. There are 128 of them, numbered from 0 to 127. Not all of them are printable. Some of them are these weird things. This is left over from the days when people programmed, but they did not have screens. They did not have screens. What they had is they had a thing called a teletype, which was like a typewriter, and it had a box underneath it which had accordion folded paper. And the paper would feed up through the teletype, and you would type, and it would type things on there, and it would send the message off to the computer. And when it came back, the computer's response would be typed, and you get this continuous roll of paper that could be hundreds of feet long that showed everything that you had typed. And so, like most of the stuff over here in this first column, all of these weird things are actually teletype control characters. It's just we're stuck with them because like everything has been written to use this, right? Does that make sense? Like, where does the English alphabet come from? Latin? Hundreds of years ago, we're still using the same alphabet. We could come up with one that was more efficient, but we're stuck with it. Okay, this doesn't have very many characters. There's actually other things called UTF that have tens of thousands of different characters, including those funny emoticons you have on your phones and foreign languages and stuff like that. All right. Yes, sir. Yep. Yep. No. That's how many things to get. Start at position 0 and get 4 things after that. I screwed up when I did the number example. I said 50 and 54, which said start at position 50 and get 54 things after that. Different languages have different ways of doing this, and so, yeah. Yes? Yes. It's start in the 0th place and take that 4 things, including that. Yes. All right. Everybody good on this? Substring? These make for great exam questions, by the way. So remember, substring like at starts counting at 0. Like at, it starts counting at 0. Now, there's one more thing I need to show you about strings. Teaching you this makes me sad. Okay? I wish I did not have to show you this, but I do. We all remember that C++ is a descendant of a language called C. Does not use the same type of strings that C++ does. Okay? So you have what are called C strings or C++ strings, which we'll just refer to as strings, but you have things called C strings. On occasion, we do absolutely, positively need to know how to convert C++ strings into C style strings. And we have to know how to do that. So the way we do that is just like that. There is a method that is called C_str, which converts your C++ string to a C style string. All right. We're going to need this later. The reason for this is we're going to need it because later when we are reading from files and we're telling the computer to get data out of a file, we are required to use C strings to tell it which file we want. It's annoying. We'll get to it again later, but later we're going to need to use this because when we tell the computer what file to open up, we have to use a C string to tell it which file to open instead of a C++ string. But no. So this is how we're going to use it. When we need to convert it to a C string, we will put .c string after it. You will never actually see the difference. And in fact, if I just go ahead and I print this out, if we compile this and run it, oops, compile it, ENDL, that would help. Compile it, and I run it, here's what's going to happen. It's going to type out clay shields. It looks absolutely no different to you, but internally, to the way the computer is processing this data, it's very different. Like I said, this is sad. This is like, it's like one of the irregular verbs of things, right? Where everything's flowing along fine, and then all of a sudden there's a weirdness that you have to do. This is like one of those. So I just want to show you this is here when we talk about reading from files, which will probably be next class. We will see when and where to use this. All right. Does that make sense? Yes? Mm-hmm. Mm-hmm. Yep. It's just printing clay. And in fact, I can prove that to you by does that help? All right, everybody good? This is pretty much everything we need to know about strings. Strings are very useful. We speak in strings, we think in strings, sort of. So we need to be able to work with them. Yeah. Mm-hmm. Yep. Because that would be 5. We start counting at position 0, and then we take 4 things. 1, 2, 3, 4. Does that make sense? That's fine. All right. Have a good weekend. Is today Thursday? Good weekend. See you next week.